Hello, and today's learning target is I can determine if two lines are parallel or perpendicular. So remember, if the slopes are the same, again that's m, or the number in front of x in y equals mx plus b, the lines are parallel. If the slopes are opposite reciprocals, again remember you change the sign for the opposite reciprocal slopes, then the lines would be perpendicular. So let's determine which of the following lines are parallel, perpendicular, or neither. Okay, so I see the first two lines here. This would be 1, this would be 2, and this would be 3. Numbers 1 and 2, I already see their slopes, right? Because they're already in slope-intercept form. So the slope for line 1 is 2/3. The slope for line 2 is 3/2. But I want to figure out the slope of the third line because, again, I want to figure out if the lines are parallel, perpendicular, or neither. Okay, so let's take a look at number 3. I want to write that into slope-intercept form so I can actually see what the slope is. So I'll subtract 2x and get negative 3y equals negative 2x plus 8. Then I'll divide everything by a negative 3. So y equals 2/3 x minus 8/3. So the slope of this third line is 2/3. So I see that line, or numbers 1 and 3 actually have the same slope, right? They're both 2/3. So I can say line 1 is parallel to line 3, and that symbol there with those two lines, it's like two diagonal lines, that represents parallel. So line 1 is parallel to line 3. Now line 2 is 3/2, 3/2. So that's the reciprocal of 2/3, but it's not the opposite reciprocal because the signs on the slopes are all positive. So not the opposite reciprocal, just the reciprocal. So that line actually is neither with lines 1 or 3. And when I say neither, the slopes don't relate. So neither parallel or perpendicular. All right, let's take a look at the next example. Okay, so I see here line 1 is y equals 4x, 2 is x plus 4y equals 12, excuse me, and 3, 4x plus y equals 1. So on the first example, right, I can write down here that m equals 4 because that one's already done, but now for number 2 I have to rewrite into slope-intercept form. So I'll subtract x and divide everything by 4. Y equals negative 1/4 x plus 3. So here the slope is negative 1/4. And then on the third example, I'll subtract 4x and get y equals negative 4x plus 1. So here the slope is negative 4. So if I look at all the slopes, and again it might be helpful to highlight 4, negative 1/4, and negative 4, and if I look at these, I see that 4 and negative 1/4, so 1 and 2 have a relationship, right? They have a perpendicular relationship or opposite reciprocal slopes. So 4 and negative 1/4, again, if I would change the sign of that fraction, they would be the opposite reciprocals of one another. Now m equals negative 4, isn't the same as 4 because it's negative, and negative 4 is not the opposite reciprocal of negative 1/4. So number 3 is not really related perpendicular parallel wise with the other two lines. So I can say here line 1 is perpendicular, and that's the sign for perpendicular to line 2, and that would be it because line 3 doesn't have a parallel or perpendicular slope with the other two lines. Okay, let's take a look here at the last example. So y equals 2/3 x minus 9 has a slope of 2/3, and then 3x plus 2y equals 6, and we cannot determine the slope from here yet because this is not in slope-intercept form. So let's rewrite this by subtracting 3x first to both sides and get 2y equals negative 3x plus 6 and divide by 2. So I get y equals negative 3/2 x plus 3. And again, I want to look at this -3/2 there for the slope. And 2/3 and -3/2 are opposite reciprocals. So we can say that these two lines are perpendicular. And again, that's because the slopes are opposite reciprocals. Okay, let's look at a few more examples in our notes. Consider the following image. Is line BE parallel to line AD? So that line right above BE and AD means line segment. So we essentially want to know if, and here in red, BE, so here's B to E, is parallel to AD. So here is AD. So by looking at the picture, do those two lines intersect? Well, they do. So we're thinking they're not going to be parallel, right? But let's go ahead and let's find the slopes anyway. So in red, I'm going to find the slope of BE. So I'm going to draw in my rise over run. So if I start with B, I'm going to go down 2 units. To the right, 1, 2, 3, 4, 5. So BE has a slope of -2/5. AD, right? Let's rise up and then run over to D. So rise up 1, 2, 3, 4, 5. Over to the right 1, 2. So BE's slope is -2/5. AD's slope is 5/2. And we could already tell from the picture that they weren't parallel, but we just confirmed that they have opposite reciprocal slopes. So these two lines would be perpendicular, right? They would not be parallel. They would be perpendicular. Okay, the next question says, are lines AE and CG parallel? Before we go on, I'm actually going to erase what I have drawn over here just so I can see the picture a little bit easier, to make sure you have the previous problem written down. So let's look again. AE is this flat line right there, and CG is that flat line right above. And so we're asking, are those lines parallel? So let's find the slopes of both of them again. And from the picture, hopefully you can kind of already see what's happening. But let's go ahead and let's solve for the slope. So AE, I rise up 0. Okay, I rise up 0. And then I run 1, 2, 3, 4, 5. So 0 over 5, which is 0. Now for the next one, I rise up 0 and I run 5 again. So 0 over 5 is 0. So my two slopes are both 0, so that means they have the same slope, so they are parallel. So we could say, yes, they are. And again, we confirm that because we know that their slopes are the same. Okay, let's look here at this last example. J-Man Road passes through the points -6, 2 and -1, 8. D. Schultz Road passes through the points -3, 6 and -8, 5. Are these two roads parallel, perpendicular, or neither? So I'm going to first look at finding the slope of the first road, and then the second one. And so if I want to find the slope, again, remember that formula, y2 minus y1 over x2 minus x1. So I can label x1, y1, x2, y2, x1, y1, x2, y2 to find the slopes here. And so for the first one, I will have 8 minus 2 over -1 minus -6. Chop, chop is really plus. 8 minus 2 is 6. -1 plus 6 is 5. Okay, and then for the next example here, I have 5 minus 6, again y2 minus y1, over -8 minus -3. Chop, chop's really a plus. And 5 minus 6 is -1. -8 plus 3 is -5. So that simplifies to just 1/5. And then this slope here was 6/5. So are they the same slope? They are not the same slope, so that would mean that they're not parallel. Are they perpendicular? Do they have opposite reciprocal slopes? Well, no, because 6/5 is not the opposite reciprocal of 1/5. And then, so that means that they will cross, but they won't cross at a 90-degree angle, so they won't be perpendicular, and they obviously aren't parallel because they are not the same slope. So we could answer this question by saying, neither. They're not related perpendicular or parallel wise, so we're going to say here that they're neither. Thanks for listening. Have a great day. Bye-bye.